I want to talk about limits using the graph, kind of talk about what they mean. So you can see this first one's the parabola, but it's got a hole at 3. And so we're trying to find the limit at 3 here. And so when we look at this, you can see here that this side is coming to 1 and this side is coming to 1. Now this doesn't actually exist at 1, right? There's a hole there. So the limit at the function at 3 doesn't exist. There is no answer, right? I would get does not exist. But the limit does, because we don't care if we get there or not. We just care that we're going in the same direction. We both have the same goal in mind. We both got the same parking lot. Doesn't matter, we both didn't end up in the same parking spot. So this limit would exist, and it would be 1 because both sides are going to the same place. So both ones coming in, they're going that same place. The fact that they never get to 1's okay with us. They were both going in the same direction. Now, when I look at this one, I can see here that this side, the left side, okay, so the negative side, this would be 5. This one here would be 3. So this limit at 3 does not exist because they're not equal, both sides. Now we don't care that the round circle, the fact that the function doesn't exist at 3 doesn't phase us, but what does is that they're going to two different places, kind of like two streets that should meet up, but they don't. I pulled into one driveway and I thought I was going to that building, but I really wasn't because it was down a street and they didn't line up right, okay? So these don't line up, they don't meet at the same place. So because the left side and the right side don't agree, there is no limit here. Okay, we could do left and right side limits, and some classes get into that. We aren't at this point, but that is a possibility there as well. Okay, exit this. You can see here this one's a similar thing. They're both coming in at 3, but they're going to different places, so this one wouldn't exist. Now what about this one? So this is an interesting case. See, this is an asymptote, right? Okay, and so you can see that this asymptote is going off this way, and this asymptote coming here. They're actually going in the same place, right? They're both going towards the asymptote, and they're going off to positive infinity. But positive infinity isn't an actual fixed number, so it's considering not exist. Now you will see some problems will have you write down that they're going to positive infinity, and that would be an answer here. Both sides are going to positive infinity. But since positive infinity isn't a specific number, the limit technically does not exist. So this one's a little bit different, but these are these asymptotes. And so you've been using asymptotes all the time. You just didn't realize you were already doing limits when you did those asymptotes. So, big thing, the takeaway from this is that for a limit to exist, the right and left sides have to equal each other. They have to be going to the same place. We don't care if they get there, but they have to be headed to that same place. And they have to be headed for something that we can as a fixed number. So even though this last one is both heading off to positive infinity, we would consider that doesn't exist. Although sometimes, as I said, depending on how you're asked, you might write down that it is going to positive infinity. And like up on both of these, you could write left and right side limits, but then the limit as 3, a two-sided limit, doesn't exist. So, there's kind of some wiggle room in here, and depending on what class you're taking, they'll look at that. But the idea here being, we care where we're going, not where we actually end up.